Okay, today we will see this concept that you are familiar with is the data science workflow. And like now we have been doing the different data science projects, and we've seen how to tackle our problems, and we already know the steps and by default. So like let's in real life, what are the main concepts? We can just wrap them up to some specific parts, and what are the important steps, and what do we mean just by even saying like what do we mean by data science work or general data science. Okay, so let's start from the introduction, and we can define the term itself as a workflow. It's a systematic sequence of tasks, so that outlines the things and steps required to complete the whole data science project successfully. So there are different steps that we need to follow, as I mentioned earlier. Honestly speaking, those steps are not new. You already know much of the steps by now. So basically, we'll say just a roadmap for data scientists, and they will provide where should we start from, how should we communicate with the stakeholders, or what is the step, what do we need to ask from the persons that are working with us, and what is expected from us, what type of challenge are we going to face while doing the whole data science project. So you might, like on the challenge that you've been experiencing here, you might not have gone through every steps, because some part of the step, you were asked to do specific part of the whole data science projects or different projects. But as a whole, when you are about to receive a data science project, it might include every step. So what are the steps? So it empowers data scientists to collaborate efficiently and effectively when extracting value from data. So as you've seen, there are different steps. So maybe one of the person might do the EDA, and one of the person might do the modeling. As a it's not specific for that task, maybe for the EDA, maybe for the cleaning the data, or for modeling the data. If you're a data scientist, then you need to cover, the whole part is covered, so it will help you to collaborate efficiently with other people, so that you can divide the task between each other, and you know in which part of the process or the workflow that you need to focus on. So the key steps are: the first one is like defining the problem, as we always say. On our case, we have the business understanding or the business objective. Then we define the process there, right? So I guess you guys are hearing my voice. Yeah. Okay. So on the definition stage, it involves clearly outlining the project in order to ensure that efforts, expectation, and resources are aligned with a shared purpose and direction. By understanding the problem, it means that what problem is the person trying to solve, or the business owner or the stakeholder or your client is trying to solve. Not only that, on what extent, what is the scope? So can we just go deep, and can we just try to be perfect on our, we need to be perfect, but are we trying to solve every problem, or are we trying to solve part of that problem? But we need to understand that problem, and we need to understand how further that we're going to go, and what amount of effort are we going to put on that project. And during defining the problem definition phase, it's essential to involve stakeholders, because from the business and from the data science team of like the stakeholders. So it will help you to gather diverse perspectives, clarify expectations, and ensure that the problem statement is well defined and actionable. Okay, so like they might be ambitious because they might not understand this side of the solving the problem, or the data, the tech part or the tech aspect. So like you need to be, is that are they being too ambitious, or they have a problem that can be solved, and they do the problem have the problem they provided is solvable within your resource, like knowledge resource, human resource, and other sources. So you need to understand the problem, you need to define the problem, and you need to go deeper on that. At the end of the day, if it is not solvable, you might have a lot of experiences, a lot of knowledge there, and time at the end of the day might not solve the problem. If the problem is unsolvable on the current situation or the current scenario of the stakeholders and your situation. The other is the data collection or the data acquisition. So you need to technically just data collection is having the data or enough data for the projects that you're going to do. So there are different type of collecting your data. So you have seen on this on different tasks. Some of them is you've been scraping data right from Telegram and from another data source. So in order to perform a meaningful analysis, you need to have an accurate information. So the data is needed. Also, you need to make sure that the data is accurate and up to date, and you can rely on the data in order to make the analysis. So, having the right information or having the right source of the data is also important. So, team of identification of your data source, like retrieving data from, you might retrieve it from database or another APIs, picking data from websites, or even generating synthetic data. So there might be different sources of collecting the data. This is the technical part. I mean, the technical way of collecting the data is collecting from different sources. So it's even one, uh, one type of job, like people, you might hire someone to collect the data from different websites to retrieve the data. Okay. So it's not just collecting the data. If you are a tech person, at the end of the day, if the data is not clean as you want, and if it needs to pass my pre-processing part, then it's going to be a burden. So, while collecting the data, you need to ensure that the data is accurate, and also as much as possible, the data is reliable and um, accurate and reliable. So this is the data requirement. What you need is the data requirement first, and then preparing the data source, and then the authentication, or if the data source that you're going to get future data from is real and accurate. So this is the second step. As you can see, there are you can just name the steps, but none of the steps are you know none of the steps will perform less if you're going to compare every step. So like every step is as important as the other one. And then there's after having the data, you need to clean and pre-process the data. So we've been seeing many parts of doing this. So one of it is the ED. So on our EDA, we used to explore the stage involves understanding the main characteristics of the data. Before understanding or before making some analysis from viewing our data, we need to clean it and prepare the preparation stage, which is processing the raw data in order to achieve a consistent and structured format. So that is well suited for reliable analysis. So we might handle missing values, outliers, encoding categorical variables, and scaling. So like, is there, maybe you can just say if there is, how is there any step that we haven't done on the previous weeks? Like we were dealing with missing values, we were dealing with outliers, we were encoding categorical variables too, and maybe scaling. That is, yeah, we were normalizing of some challenge. But like, is there anything that you've missed or that you have not done from your previous challenge? Maybe, is there anyone? You can just write it here. Do you think there is any part or any method of pre-processing or cleaning the data that we have not demonstrated from the ones mentioned here? Are you guys can you hear my voice? Yes, thank you, Itaso and Tamara. So maybe is there any step that you have not seen earlier? Everyone did it, so I think that we have not done on the previous challenge, like handling missing values, outliers, following categorical variable scaling, or if there's any other method or pre-processing method that we have done, but that is not mentioned here. Let me check that if you guys are audible. So maybe 4% can say something on this. Yeah, maybe I guess it's fine. I guess we have seen you guys have performed every steps, starting from the easiest one, which is handling the missing values, to scaling, normalizing, and I also believe that you have made another different pre-processing methods rather than the ones mentioned here. So, and then there's the obvious and the famous part, which is the AD. So, the exploration stage, here it will involve the understanding the main characteristics of the data, even if it is clean, even if it is collected carefully, and even if it has some pre-processing for data can have different type of characteristics as we know, right? So it might be biased, it might have some issues by itself, even like some issues that you cannot clean by just like you cannot ignore by just cleaning the data. So we might we might take different steps in order to see, in order to notice the characteristics or the yeah, the characteristics of the data. So in order to formulate valid hypotheses, identify issue, and refine the project proposal. So the goal is to identify if there is any pattern or if there is any correlations, anomalies, and potential insights that can guide further analysis. So maybe there might be like a very large amount of view that you can see. You might say like if you're computing maybe fraud. One of the examples that we are familiar to is fraud detection, right? So if we are dealing with fraud detection problem and if you have got like around 99 frauds out of 100 data, you could just stop the work on the day. But, you can just say that it's really nonsense to do a fraud detection, or maybe like better than the fraud, maybe you, let's assume that it is an insurance company and you're trying to determine if uh, the low risk people in order to get the insurance. So if majority of or 99 of the person have high risk, are on the high risk and they don't deserve the insurance, and then you could just say that there is no need of identifying, like, doing any further work on this specific city because majority of the people are at risk. Okay, so like you might have you need to have an insight, but also sometimes an insight that can guide you for a decision on the day. So it's one of the major parts. So it will help us to understand the data distribution, relationships, and patterns. And then there's the feature engineering and selection, which is you can create a new feature, dimensionality and dimensionality reduction, and also feature selection. So, uh, so so the more data we have in every case, the more reliable our prediction or our work will be, right? So, feature engineering will help you to gather another parameter on another feature or another parameter, depending on the one that is provided. So I was asking you guys because we all have worked. You guys have worked on every section or part of this, so like it might help you. You can just participate and you can just tell a different part of it during different part of ED. I mean, pre-processing that you have done before. And there's the model building and evaluation part, which is also the major task. I can't just compare and say one of them is non-major, but as I mentioned earlier, so the modeling phase will focus on building statistical or ML models that can provide predictive power. Okay, so it involves selecting appropriate algorithm that we can start from selecting algorithms or ML methods that are appropriate and that can work with our uh, current work, right? And then training the models using the prepared data and evaluation of the performance. So from the beginning, the data scientists deploy different modeling techniques, including like there are different one, right? The regression, classification, maybe clustering. Also, you might go to the neural networks and you might choose different models. It depends on the nature of the problem, as we always say, and what type of data are available and what type of uh, even if we're using some type of deep learning, we might need a better amount of data than using the normal ML models, right? So during this phase, it's crucial to consider model interpretability. So how are we going the interpretability, the generalizability, and the scalability? So not just working with the models and predicting, but also After doing this, like besides the evaluation, how are we going to interpret the results? How are we going to say, um, we've been using sharpened uh, another methods, right, in order to interpret our models. So, um, are they? We need to consider that part also, and also scalability. So, since maybe we are just testing our models on a specific amount of data, and so like how do they will this perform, or will they be able to perform a large amount of data, or on a live session, or by working directly with the models. So it will involve alternatively you need to refine and optimize the models based on the evaluation metrics. So um, by default there are different, right, evaluation metrics like accuracy, the precision, the recall, the funds parameters that are made that are already stated, and you can just use those type of evaluation metrics to compare your models and terminology. So techniques such as cross-validation, hyperparameter tuning, and ensemble methods are mostly used in order to improve model performance. So you might also change the models since we also, as mentioned earlier, we need to keep in mind that what type of model are we choosing for that specific scenario or case, right? You can't just pick one model, right? So like um, after, like, if you have decided that model is the best to perform with the situation, you could just play the model by working some cross validation and hyperparameter tuning and another methods so that you can improve the model performance. And then the deployment and communication. So the last one is a method unity. So at the end of the day, you need to find a way in order to put your model as a usable format. So you might uh, involve deploying the models. You might need to deploy them into production and communicating the result to stakeholders. So, by deployment, it involves integrating the models into existing systems or creating a standalone application or APIs for end users if the model is if it is going to work alone. So you can just keep it as a standalone API or system or application, or also mostly it's integrated with another software or another system or another um, existing system. So you can also integrate it with another one. So like this is the common workflow of ML workflow that we were doing, and so like it is put as a common practice of the workflow. So yeah, just keep this in mind. It's I'm sure that most of us are familiar with all these concepts, but we need to stay, since we have used different type of, we have worked with different type of data models and also predictions, results, evaluation. So now just like it is time to generalize everything and put them in, put them as a pro, like word, like many different projects for specific on this specific on this specific work. So, so is there any question on this? I'm not sure what type of question we have done. Danny, thank you. I haven't seen that. Yeah, we have done different type of, and yeah, it is. I feel like it is the time that we're going to be familiar. We need to be familiar with different terms of any aspect, like if it is of the data collection, data scraping, retrieving data from the database, and anything and anything. Okay, if it is data cleaning the data, we now are familiar with outliers or changing your values or some values, missing values to their mean value, adopting the values and things like that. Daniel, I guess you were disconnected, and I say thank you for that we have the message. I haven't noticed it. So, and also if we go to the data modeling, so now we're familiar with any type of models, and also if there is a, we are familiar with methods that are going to be used in order to improve the model performance and evaluate the model. So like it's time to generalize every concept and check for something that check if there's something that we are missing. So what do you think? Like it's a common concept. The seeing every flows and every steps of every step of the workflow. What do you feel like? Do you feel like now you're ready, or now you're like one of the data scientists? How we can say like you are you cannot be senior, but you are well educated junior data scientist. What do you feel about yourself? Maybe you can share us. Maybe you can write it here if you understood the question. Italy, thank you. I guess yeah, I could also say that you are uh, a very good junior data scientist too. Any other suggestions? So there is just you need to see or check yourself, and you need to. It will be helpful to have some reference about ourselves, depending on like based on this information. It would be a good self reflection, the whole concept of knowing the whole concept of data science workflows and all the steps. It will help us to see ourselves, I guess. So thank you guys for being here. And if there's any question or suggestion, let's hear from you. See Daniel, thank you. Okay. I guess Amara. Okay. I guess we all are good. Then we can end the session here. Thank you guys for being here, and yeah, good luck.